So this is lecture 6. We'll see what kind of questions it has. So the first question, this kind of question is totally different from what we have been considering or doing. So this question has nothing to do with permutations and combinations. But since permutations and combinations is about counting, we are again trying to count some kind of pattern or some kind of number of ways that this can be possible. So we are still counting. So it says in an examination there are 3 MCQs, 3 multiple choice questions, and each question has 4 choices. Each question has 4 choices. It says over. What are the number of ways that the student can fail to get all answers correct? So it says fail to get all answers correct. So the easiest way to think about this is that you can write all the 3 questions. So let's say there are 4 options which are, let's say, call them A, B, C, D. A, B, C, D. So there are 3 questions with 4 choices. I just wrote them over here. So let's first consider how many ways the student can pass. Meaning there is only really one way to pass if you think about it. If you think about it, there is only one way that a student can pass all the questions correctly. He can get all the questions correctly only one way. So let's say the first question answer is C and he marks it C, and the second question he gets B, and the third question he got D, meaning he gets all the correct answers in one go, because you can get all 3 questions correct only in one possible way. Now it says how many possible ways can the student fail to get all the questions incorrect. So let's consider that, meaning we saw that there is only one possible way that you can get all answers correct. And what are the total number of ways that a student can attempt this? Meaning there are 4 times 4 times 4. 64 ways. 64 ways you can attempt these 3 questions, because there are 4 answer choices to each question. So you can just subtract 64 times 1, meaning there are 63 ways that a student can fail to get all answers correct. So this is the easiest way you can do this. You can just subtract the one way that it is possible to get all answers correct from the total number of ways. So 63 would be the answer. So this question is a little bit different, but very easy to think about. So let's move on to the next question. So this is the second question. It is pretty similar to the questions we considered in the previous lecture. So let's talk about this. There are 6 teachers, out of which 2 are primary teachers and 2 are secondary teachers. And the remaining 2 are obviously middle teachers. So there are 2 primary teachers, 2 middle, and 2 secondary teachers. Meaning there are 6 teachers in total. Now they are saying that you have to arrange them always in a set. So they have to be in a set. So again, the order matters here. We are talking about teachers or people to be arranged in a certain way. So we are considering order. So order in which they come matters. So again, how many possible combinations or number of ways it can be arranged when we consider order for 2 of those teachers is obviously 2, because 2 factorial is again 2. There are only 2 ways that you can arrange 2 teachers, meaning let's say there is one teacher named Mr. Anuj, and then another teacher which is named Mr. Karthik. So there are only 2 ways that those 2 can be arranged. Anuj comes first and then Karthik comes first. So again, similar idea for middle school teachers and then secondary school teachers. So 2 factorial each, which is again 2. So meaning there are 2 into 2 into 2, 6 ways that we can arrange them all. Now you have to also consider them as a whole, because remember when we were talking about words, when we had vowels and consonants, we were talking about vowels differently, but then combining them as a whole as well. So let's combine them as a whole, meaning we just said there are 6 teachers, right? So, and each one of them, it is divided in 2 primary, 2 middle, and 2 secondary teachers, meaning there are 3 types of blocks. We can divide them in 3 different blocks. So one for primary, and one for middle, and one for secondary. So 2 each. So this thing that it's divided into 3 blocks is 3 factorial or 6 ways. 6 ways that these teachers as a whole, as a set, can be arranged. So now you can multiply all the numbers that we just got. You can just calculate that, meaning we got 48 ways or 48 different number of ways that these teachers can be arranged. So all I did again, if you remember back in the words case where we were considering vowels and consonants, we were combining them all at the end. So similar idea here, these 3 blocks, 3 factorial, which is 6, and then multiplying them with each one of the block, which is 2 times 2 times 2, you get 48 ways. Another thing to think about is that you can look at the answer choices. You have 52 and 34. So let's forget about the none, because we don't know about none. But 52 and 34 obviously have prime factors. So 52 has 13 and 34 has 17. We know that we don't talk about prime numbers you cannot talk about prime numbers or prime factors in these kind of questions, in counting questions, in permutations and combinations, because prime factors are basically prime numbers. They don't divide or multiply. They don't divide. They don't have any other any further factors that they can be divided into. So the answer is always even number and something that doesn't have any prime factors. So which is 48 again. You can also think about this in terms of number, talking about number, applying some common sense. So, but the answer is the D has none options. We also have to consider. We also have to solve this, which we just did. So it's pretty easy. So 48 is the answer again. Thank you.